All right, let's practice another trig integral. This one is quantity squared minus a number squared. So that one looks like the identity secant squared theta minus 1. So you got quantity squared minus, or variable squared minus a number squared. Now we got a 25 here, we got a 1 here, so we're going to have to multiply through by 25 in order to match up the constants. So that'll give us 25 secant squared theta minus 25. So now our constants match up, so our x squared has got to be equal to this part. That gives our substitution. So our x squared has to be 25 secant squared theta. And our x then will be 5 secant theta. And so our dx will be 5 secant theta tan theta. Derivative of secant is secant tangent. D theta. And now we can go ahead and change the integral over. So in the numerator, x squared minus 25 is right here. So it's 25 secant squared theta minus 1. That is under the square root. In the denominator, we've got that x squared, which is 25 secant squared. And then our dx out on the end, 5 secant theta tan theta d theta. So there's our trig integral. So now let's go ahead and simplify this. So integral on the top, this is tan squared. So that's really square root of 25 tan squared. It's a perfect square, which is why we're using these trig substitutions, because they get rid of the square root sign with a perfect square. 25 secant squared in the denominator. And then a 5 secant theta tan theta d theta. So square root of 25 there is 5. Square root of tangent squared is tangent theta. In our denominator, 25 secant squared theta. And then we've got 5 secant theta tan theta d theta. So 5 times 5 is 25. It'll cancel out that one. So we are left with a tangent squared secant over secant squared. We could cancel one of those secants, and we would just have tangent squared over secant. But before we do that, we notice here, let's see, we do have a secant squared if we want to solve the trig integral, but it's in the denominator. In the numerator here, we have a secant tangent. So this is actually going to be our du. And then our u is going to equal secant theta. So if we do that, then let's see, this would be u squared, and then the tangent, let's see, tangent is going to be square root secant squared minus 1, square root u squared. No, that's not going to help us. So I think we might have to take a different approach here. So we don't want to use u equals secant. We can cancel here. Go ahead and cancel one of those secants. So we are left here then with integral tan squared theta on top over secant theta d theta, right? 2 tangents on top, 1 secant theta is left in denominator. So we don't have a secant squared, we don't have a secant tangent. Why don't we change these things to sines and cosines and simplify? So this will be integral tangent squared is sine squared over cosine squared. So sine squared theta over cosine squared theta. And then your secant, remember, is 1 over cosine theta. So we're dividing by 1 over cosine theta, so we're going to multiply by cosine theta over 1. And let's see, this cosine will cancel one of those. So we are left with the integral of sine squared theta over cosine theta d theta. And then sine squared, we can trade that out for a 1 minus cosine squared theta. Cosine squared over our cosine theta d theta. And then we can split these apart over the LCD. So integral 1 over cosine theta minus cosine squared over cosine d theta, which will be 1 over cosine is secant. So we're integrating secant theta minus this cosine, I'll cancel 1 on the top, cosine theta d theta. And so we know how to integrate cosine here. That's easy. That's just going to be sine theta. And then the integral of secant theta, that was a trig integral. If we go back and look, that was in powers of tangents and secants, and it was the very last one. And that was one that I said you could just use the formula if you ran up against that. So that is here. Where do we go? Right here. Integral of secant x dx is natural log secant x plus tangent x in absolute value. So this will be natural log absolute value secant theta plus tan theta, and then minus antiderivative of cosine is sine theta, and then plus constant. And so we got our integrating done. And now we just need to reverse the substitution, go back to x's. So we draw a right triangle. Here's theta. Our substitution is right here. X is 5 secant theta. So that means divide both sides by 5. Secant theta is x over 5. Forgot my theta. And secant's 1 over cosine. Cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. So our hypotenuse is x. Our adjacent side is 5. And then this side will be square root hypotenuse squared minus leg squared, 5 squared, 25. So root x squared minus 25, and double check here. That is in our original integral right there. It's the numerator. So now we can reverse our substitution. Natural log, absolute value, secant theta is x over 5. And then tan theta, opposite over adjacent. So here's our opposite, here's our adjacent. So root x squared minus 25 over 5. And then sine theta, opposite over hypotenuse, opposite hypotenuse. So root x squared minus 25. And then over hypotenuse of x and plus a constant. And lo and behold, we have our antiderivative.